Okay, here we go. What do we do? 2 through like 42 maybe? 36. There you go.
And I need help on 20 through 36.
Okay. Which ones are those? Oh yeah, we can fix that easy peasy. But let's go over the answers first. But then yeah, we can you got this. You said 20 through 36 or 20?
2 through 36.
I know, but I was like
I got stuck and I can.
on number 20.
20, 22, 24, I tried 3 or 4 of them. And
Okay.
it's like I can't get it.
All right, that's not going to be a problem. We got this. All right, so number 2 is no. Number 4 is yes. Number 6, I know, sorry if I'm having a conniption. Number 6 is no. Number 8 is no. Number 10 is yes. 12 is yes. 14 is no. 16 is yes, and the inverse is x equals, x squared minus 8, and x has to be greater than or equal to 0. Number 18 is no. Number 20 is yes, and the inverse is negative 6 over x minus 1, and x cannot equal 1. Number 22 is yes, and the inverse is negative 3 plus 49, and then just the 49 over x squared, and x is greater than 0. Number 24 is yes, and it is 5x, the inverse is 5x plus 4 all over 3x minus 1, and x cannot equal 1/3. 26a is y equals x over 1.6, and y equals speed in miles per hour, and x equals speed in kilometers per hour. 26b is a graph, which I'll pop up there momentarily. 28, oh, it's on another page, so everything is momentarily.
I just realized that I accidentally switched the instructions for 14 through 24 and 2 through 12. I did the opposite instructions for those sets of problems.
Okay. What am I pulling up? I'm pulling up, oh, 26b, it's right there. And then 28 through 36 is all of these things.
0.8.
Huh?
What 0.8?
What, 0.8? That's the 8th of the random crap series.
Awesome.
Yeah.
You have a series?
Yes.
Your notes are in a series? What season are we on?
Season 1 as well.
First thought it was like the lesson, and I was like, but no, we're on lesson 7, and it's
Yeah.
not even.
All right, there is 26b, albeit a little blurry, but there it is. And I don't know why I took a picture of these, but here we go. This probably is an easier plan. And since Aiden isn't here yet, let me flip the camera around so he can see.
These are all coming out on 28 through 36, all the inverses, right?
I didn't read them all yet, but it kind of looked like that I didn't see any, no, there's not any inverses. So on 28, the key, which was potentially helpful, it's showing you all the work. What we got to do, what you're doing there is finding the composition, right? So on 28, we proved it because the composition equals x, and then the other composition equals x. Same thing on 30. So we can actually work some out if we need to, but when you do the composition, you simplify them, it equals x. So they're showing the whole thing, which would be the proof, and showed that it is. So same thing on 32. We did through 36, 36, okay. 34, same idea. Much more 34 is uglier, right? Because it's got the square roots in there, so you got to do a whole lot of mess to simplify it on down. This whole This whole 2 lines was simplifying that first one, and same thing on the second one, but they are inverses. They are inverses. 34 is just much more of a pain to show that. What?
You have to write out all of these, there can do multiple steps in one thing.
As long as it's reasonable and you're showing the work that you need, that's fine. All right, and then 36 is partially invisible. And ugly. True enough. I suspect we're going to do it in a minute, so I won't waste the time putting that up on the camera. Are we going to have a question on 36? Probably.
Yes.
Definitely. So there we go. Let me flip the camera back around, and we'll take questions.
Read 20 again.
Yeah, I can.
Well, I just made them to straight up show how many they did 20.
Yeah, we'll do both of those things. I'll read the answer, and then we'll start with doing 20. Sounds all reasonable.
Start with 20.
Yeah. The number after 19.
Oh, yeah. Sorry.
Because the number of the fractions and stuff, I didn't understand how they did their reciprocals.
19.01.
Their reciprocals, I thought it made sense,
But then something was crazy. All right, so number 20, the answer was yes. And the inverse is -6 over x minus 1, and it can't be 1. All right, so starting with 20. So we want to determine whether or not g of x equals x plus 6, right?
X minus 6.
X minus 6 over x has an inverse. It does, in fact, have an inverse. That's true. So we want to determine whether it has an inverse, and if it does, we're going to find it and state any restrictions on its domain. Okay, so what should we do? Switch the x and the y's. Great. So you could see whether it does. So does I don't remember on these instructions. Does it tell you to use a graphing calculator to determine it? First one does. So answering the first part, so the first part of the determine whether each function has an inverse function, I would do that with the graphing calculator. And it's got to pass the horizontal line test, which is like the vertical line test, but horizontal, right? So it does, in fact, have an inverse. It passes the horizontal line test. So in order to find the inverse, yes, we switch the x and the y. So we're going to put an x over here and a y everywhere there's an x. And then we've got to solve for y. So what do we have to do to solve for y?
We get rid of the y.
I agree. Let's get rid of this y first. I think that's a great first step. Well, how's it attached to all the rest? Yeah, so it's added, subtracted, multiplied, divided, or something else. You multiply to get rid of it, right? Because it's divided. Yeah. Okay. So times y and then times y. So we've got y x equals y minus 6. What could we do now? No, that's not what we would do. No, not yet. But we want to get something to happen with the y's in a second.
1 second, I'm waiting.
I know. I'm waiting on you.
We didn't make it 2y, right? That'd be great.
No, but you're kind of thinking in the right track, sort of.
We want to get the other y on this side, right?
That is what we want. We want both of the y's on one side. So we're going to subtract off this one, right? So y x minus y equals -6.
If you wanted to, you could move the 6 over and just do more work. Or it
Yes,
would not.
yes. You're going to have to,
Do a whole bunch of crap,
well, I don't know how much more work it would really be in this particular problem. Probably be similar. Okay, what could we do now if we want to get the y?
Divide both sides by x. Move the x over.
Okay, so if we did that, so we remember that when we divide, it has to be everything, right? So it would be over x, over x, over x. So we can do that, but then we got a mess over here. So what could we do instead? Yeah, I know, that's great. I'm leaving you in the struggle for a minute. Leaving in a struggle is a great thing for a time. What are both the terms on the left have in them? They both have a y, so we could factor out a y. We factor out a y. When we factor out a y out of both of those, what's left? Well, no. Yeah, this one is 1, right? Yeah. So x minus 1.
Then you divide both sides by x over 1?
Yes, yes. So g prime, no, that's the derivative. Inverse of g of x equals negative 6 over x minus 1. Are there any restrictions on the domain that we need to notate? It cannot equal 1.
How is it an inverse?
From the picture?
Yeah.
So graphically, what is an inverse?
I don't even know.
Okay, so I wasn't sure whether I said that in the video. It's easy. I got you. Let me finish writing this before I move on to another thought. Okay. Graphically, here you go. You ready? This is what an inverse is. It's you take the thing and you reflect it over the line y equals x. So, for example, if we have the quadratic parent function, its inverse, now it actually doesn't have an inverse because when we do that and we put it over this line, right? If we were to totally reflect it, then it actually fails the vertical line test. So it doesn't have an inverse, but that's what it is. So when you take which I don't know which one you have this is the beginning, if you take this guy and flip it over, then it turns into the other thing. Flip it over that line. That's what an inverse is. Okay. What other questions do we got?
Like, how do we determine that it can't be 1?
It can't be it doesn't have an inverse. Is that what you're what?
How
No.
can it not be 1?
Okay, so this. What can the denominator not be? 0. So, that would break it. So we have to restrict the domain and say that it can't be 1. Because if it was 1, then it would break it. So the two main times when we have restrictions on the domain are if the x is in the denominator, then the whole denominator can't be 1. And then also if it's inside of a radical, right? Whatever's inside the radical has got to be greater than or equal to 0. And so you set all of that greater than or equal to 0. So
Can you do 22 since that one has a radical?
Sure, be happy to. 6 was no.
How is it no? Because it's f of x equals 4.
That is true. It fails the horizontal line test everywhere because it is in fact a horizontal line. So if I took this and flipped it over the thing, it would be a vertical line over here, and a vertical line is not a function. So that's why you use a horizontal line test to see whether it has a. So if it on the like this one doesn't have an inverse because it fails a horizontal line test because it crosses at 2 different places.
I was thinking, yeah, because it's like on a horizontal line. Okay.
Yeah, it is a horizontal line, so it definitely fails that test. All right, 22, here we come. Number 22.
Why would it take so long for it to select?
Because TI, and this is true of every major calculator manufacturer, that all of them, the calculator part of their company is like a tiny afterthought that they're hoping to make a little extra money with. TI is included because TI is not really a calculator company. TI is a semiconductor company that makes microchips and whatever else. That's their business.
And then
they
change the line to be like it does dots instead of like connected full
Oh, and it may graph it faster. Well, there you go. Tip. So did you know that those calculators, one of their main processors is the same processor as like a computer from the 80s.
Love that.
So, there was, and I don't remember what it's called, there was a calculator, Kickstarter a few years ago where somebody made a calculator, built one from scratch that was like a modern calculator. I don't remember what it was and haven't heard anything about it, but I don't know why somebody doesn't do that and replace the whole friggin' industry because it's stupid. Casio makes dumb calculators, HP makes dumb calculators, TI makes dumb calculators, they all make dumb calculators. All right, does it have an inverse?
Yeah.
Yes, great. We could,
Would it be a square root function or a reciprocal function?
yes.
Okay. Actually, I figured out
Yeah.
it
Let's find the inverse. Here we go. No. We're skipping straight to x equals 7 over the square root of y plus 3. And now we got to somehow get y by itself. There's all kinds of problems happening here.
Have to unsquare, right?
We are eventually going to have to unsquare root it.
we
Which,
have to just square everything?
Or should we get rid of the
so we could square everything to start, or we could, so we could either get it out of the denominator or get rid of the square root. Either one is something we're going to have to do. Which one do y'all want to do first?
I want to square it first and then I want to do
It's fine. Totally fine. So we're going to square both sides. This one's squared and this one's squared, and we know that if we square a fraction, we square the top and square the bottom, right? Right. So now we've got x squared equals 49 over y plus 3.
And do we do the multiply by y plus 3 in the top?
I think that's a great idea. Let's do it. Multiply both sides times y plus 3. We got to distribute it over here, right? So we end up with y x squared plus 3x squared equals 49. What could we do now? We don't mind that squared because remember we're trying to solve for y this time. So those squares can stay. They're not bothering anybody.
Take out x squared. Okay.
So we could factor out an x squared and then divide it on that side. There might be, I don't know. I don't know that that's any more or less difficult than another way to do it. So whatever. What were you going to say something different or that? Okay, great. Let's do that then.
What's the other way to do it then?
We could subtract 3x squared off both sides. That would be another thing to do. It's about, I think probably difficulty-wise, probably about the same on this problem. If you want to do it both ways and see what you like better, you can do that. Just not at the moment. What now?
Now we can divide by x squared.
Mm-hmm. Sounds great. See, this is why I like teaching pre-cal, because in Algebra 2 or whatever else, nobody would have thought to even do it that way. Factor it out. Everybody would have just gone straight to trying if they would have done anything. But pre-cal's fun.
Subtract 3.
We do need to subtract 3 from both sides. I agree. So y equals 49 over x squared minus 3.
Can't have a squared in the denominator, right?
We can have a squared in the denominator.
Oh, it's just the fractions because that makes it square root.
And in the next unit, you're going to see what that looks like.
I'm graphing it right now with the
Okay, then how do we figure out what to do now?
Oh.
Anybody wants some jello? Yes. Blue
What-
jello.
What flavor jello?
It's
Blue.
blueberry. It's not blueberry, but it's blueberry
Okay, so what can x not be in here?
So how do we put it about x cannot be 0?
So it can't be 0 because of what?
Because the net is 0 in the denominator.
That's true. And there's other things that it cannot be too. What else can it not be? It can be 7. What's wrong with 7?
1.
Okay.
It has to be, so we have to also set this guy greater than or equal to 0. So x plus 3 has got to be greater than or equal to 0. We subtract 3 and subtract 3. X has got to be greater than or equal to negative 3, right? Right.
Thank you so much.
No, I don't want any jello. I definitely don't need any sugar
It can't equal negative 3 because, sorry, I had it.
because the original.
But then negative 3 plus 3, and then you'd be finding the square root of 0.
So you
What?
Then you'd be finding the square root of 0.
Square root of 0 is okay. Square root of negative 1 is not okay. Right?
But then if you found the square root of 0, wouldn't it be 0?
Oh, you're right, because that whole thing, you're right. Yeah, because a fraction and a radical.
So you have to look at the original and the inverse when you're looking for what it can't be.
Yeah. Yes. I think the key is slightly off, because they just said it has to be greater than 0, but really, like if we were to write the entire restriction for the entire thing, it would really look something more like this. It would be negative infinity to negative 3. I don't know why I'm mixing my metaphors. And unioned with, you do that one between there and 0, and then 0 to that, so it'd have like 3 chunks. But
Can we do 36? No, wait, no. What's the stupid one?
26?
Let's do 34.
36 and 34 are both kind of big and wild.
Let's do 34.
Okay. I think we're probably going to end up doing them both, so
Okay.
may as well do it in order. Who knows? Because they're both kind of big and wild for different reasons. Arguably, neither one is actually that hard. They're just kind of long and ugly looking. All right. So 34.
G of x equals the square root of x minus 8 plus 5. Square root of x minus 8 plus 5. And f of x is x squared minus 10x plus 33. And x is greater than or equal to 5.
Yeah, I didn't know what to do with the x's.
Yeah,
Nothing, other than stuff potentially at the end. They're just saying that's a restriction on the domain.
I don't know what to do with the.
All right, so the question says something about, show algebraically that these are inverses. How do we do that?
Gotta stick them in each other.
Yeah, got to find g of f of x and f of g of x. And if they both equal x, then we're golden. So f of g of x would be putting g inside of f. So here we go. Whoosh. X minus 8 plus 5 squared minus 10 times square root of x minus, what am I doing? That's not right. That is right. 8 plus 5 plus 33. And then we've got to simplify it.
They tried to mess with you by switching the order.
What order? Oh, yeah. Yeah, I don't know why they did that. It seems,
That would have.
it's like the only one they did that on. I wonder if they just like accidentally typoed, but I mean, it doesn't matter. But maybe so. I don't know. It's just kind of silly. All right, so YOLO, here we go. What are we going to do to simplify?
The square root goes away.
The square root, the first one.
Mm-mm.
You distribute the square root and then the.
No, you don't distribute the square root.
It's 2 of them.
There you go.
You factor it, it doesn't
She said 5 different things, but the last one was right. So it's great.
What did she say the first?
Okay, so the square, it means that there's two.
No, because I wouldn't distribute because you got to do the whole thing. You got to FOIL the whole chunk out. You're going to miss a whole term in the middle if we do that.
Remember this crown root?
No, because of math.
Because it's attached to the whole thing, not just.
Now this one times that one, the square root does just poof, right? The first for the first, but the outside and the inside, it does not in fact poof. So it's going to be these, no, it's going to be x minus 8 for the first part, right? And then this one times this one is 5 times this, and this one times this one is 5 times that. So we've got 5. I'm gonna show you something that I showed you briefly in Algebra 2. A useful tool, assuming some of you do calculus or linear algebra or some other thing, is using a kind of a shortcut way of doing something. It's probably slightly waste on this problem, but it's potentially useful in the future. So I'm going to show it to you anyway.
What does U stand for?
It's another letter.
Oh, just a letter.
Right? So then we've got u plus 5 times u plus 5, right? 5u plus 5u is what?
IU squared.
5u plus 5u is what?
2U.
5u plus 5u is 10. 10u. So the middle term is going to be 10u, and u is that. So 10 that, right? It's a way to make a complicated ugliness simpler. So you do a derivative on this
For
instead of that.
Second chunk with the minus 10, you'll distribute it, is that what it's called?
You will.
And then that's going to cancel out the 10.
It is going to,
Negative.
yes.
So we just turn it x minus
Isn't
8.
it minus?
No, you get rid of it fully. Because you have positive 10 square root of.
You're going to, yeah, from this line to this line, yes.
Square root of x minus 8.
Yes.
That's the second one.
Yeah. Well, it's because we're in the middle of here, and she's talking about this next line.
Yeah, I'm saying, but like on the first line, it's a negative 10, not a positive 10.
This one is a negative 10 times that.
That positive 10 is from.
This one's a negative 10. The positive 10 is this one.
Oh, you're writing the factor right now, right?
Yes, this is the foiling of that.
Okay, that makes
This is the distribution of that. Yeah,
sense, yeah.
good.
Not quite.
Where is Mia when we need her?
No.
Wait, slow down. What happened?
10's what I do, honestly.
Right, that too.
So then the two 10s, whatever's cancel each other
That's
out.
true enough.
And then you just add a bunch of numbers and you get the 100. So x plus 100.
If it does, then we did something wrong. So let's see. Negative 58 plus 58.
Sorry, I put
Accidentally
zero.
add.
It equals 0.
It does. Yeah, so all of those are going to cancel, and it leaves us with x, which is good, except it's not good because that means we've got to now do it the other way, right? So now we've got to find g of f of x. Because if it had not worked, then we could have quit and said they're not inverses, right? But, you know.
Is it good and not good?
All right, so now we're going to plug all of that inside of there. So the square root of a huge mess minus 8. Oh yeah, this is going to be great. I see this direction is actually kind of fun in my humble opinion.
Oh, gracious cream.
What could we do?
Does all of them have to have a square to cancel the square root?
So the only way you can cancel square root is if the whole chunk was squared. Yeah. Which is not true yet.
What would happen if we just squared everything?
We don't really have a number over here to do that with, but that's a good thought.
Can we, like, factor it?
Yeah, that comes.
Well, before we factor it, we probably want to combine like terms.
Yeah.
But then I bet it factors. Because if it doesn't, then something is probably incorrect.
Oh, yeah,
Yeah,
factors.
that's factors.
Totally factors.
So you get
Wait, what? Oh, yeah, just kidding. My brain said no for a second there.
Minus, which is the same thing. I wrote it all the way out, but is the same thing as the square root of x minus 5 squared. And then it goes away. And negative 5 plus 5 is 0. So it equals x. So yay, they are inverses. We proved it.
Okay, can we go back to 24 because I got stuck?
We can. Let me grab a marker that isn't ugly.
Are these?
Your 24 is one that we did or didn't do? Oh no, 24. Okay.
No,
Where are you stuck?
I
What?
tried to do it and I got stuck.
Where'd you get stuck?
I don't even know. Here.
Okay, let me see. Oh, you stuck. Oh, here. Not here. Not the blank, but here. Okay, great. Okay.
I understand you. I understand that.
Sucks. I haven't had that braces in years.
I think you started trying to inverse too early or something.
I get them off next month.
Yeah, I'm still trying to figure out how to do this.
Oh, no, I see. Here. Oh, okay, I see. Oh, this is the original. No, just kidding. I was looking at the wrong place.
Get the big metal
Yeah.
square.
You did great. First step looks great.
Yeah, or whatever.
Next step, what'd you do? You did the distribution. Yeah, you're on the right track. And we can pick it up real quick.
So is that ugly 3
You,
minus 5?
so, like, no, I don't know if that's true or not. I didn't check the whole thing. But up to like here, you're doing great, for sure. I looked at all of that bit. And it might be great after that, I don't know. But I can look and see. We can even probably squeeze it in a quick beat and see what happens. Because I bet we still need to look at 36. Where did I set my new marker? Didn't I just get out a new marker?
Yes. Well, actually, I think you got distracted.
Oh yeah, I didn't actually get it. I was answering a question. I remember. You're right. That was confusing? Okay. Makes sense.
Actually, no, I think I got it.
You figured it out. Okay, good.
We were doing the reciprocal and not just multiplying times.
It was 24. Is that what you said? Okay. So x equals y plus 4 over 3x minus 5. And so what you did, 3y minus 5. So what you did was great. You multiplied this on both sides, so you end up with 3xy minus 5x equals y plus 4, skipping a step and a half.
And then you factor it out so it's x and then 3y minus 5.
I would not do that on this one. So you can, it's legal, but I would instead try to get all the y's on one side and all the everything else on the other side. And the reason I would do it differently on that one is because we've still got this stranded y over here. So we probably want him over here before we start doing any factoring.
So divide both sides by y?
Easier. Add 5x to both sides and subtract y from both sides. Okay, so 3x y minus y equals 5x plus 4. And now we could factor out a y. And end up with y times 3x minus 1 equals 5x plus 4. And now you can divide all that mess off, right? It is kind of magic. Yep.
TI Inspire.
And then how do we figure out what this particular one cannot be?
Restrictions, it cannot be. Let's find out.
And then 1/3?
1/3. True enough. Good.
You don't get counted off if you didn't do all the homework if you at least try, right?
Correct.
Okay.
Correct. That's accurate.
Accurate.
That is accurate.
I'm usually, because of time, I'm usually late. But today, I did the homework on time, I just didn't do it in.
Oops.
It happens, but so too often.
I still haven't turned in my homework for Tuesday because I had it done on time, but I didn't actually turn it in on time, and so
It's been frustrating.
I decided not to do it.
Well, I would do it so you don't have a 0 once I get caught up on grading.
I'm gonna do.
which will definitely be this weekend. It's gonna happen.
Well, do it.
I don't have grace tomorrow morning, so I'm gonna do lots of work tomorrow morning. I also DJ on Saturday evening, but that's not till like the evening. What?
You don't have grace tomorrow?
We don't have grace tomorrow, which is great.
That's a lot of time.
It is, but there's a dance on Saturday. Oh yeah, are you not gonna be able to go? Aren't you like working or something? I'm sorry.
I thought about
So sad.
trying to figure out if I can get somebody to take my shift, but I decided that it was
Where are you working?
what?
Market Street.
Oh, you're
All right, any other questions on this lesson?
How in the world do you do 36?
Okay, so we do need to look at 36. I thought we were going to, but then we were like not yelling about it, and so I thought, well, it is wild.
What was that?
That was 24.
Oh, I thought that was 36.
No.
That makes so much more sense.
Unfortunately not.
Okay.
Numerator was.
F of x.
X plus 2.
This is a fun problem too. I like this one. X minus
If
6.
you have the same thing in the numerator and denominator, can it cancel out?
It turns into 1.
Okay. So f of g is actually easy.
Nice. I think they're both going to be a lot easier than they look, but we'll find out. I think. We certainly could be wrong. They could be ugly and horrific and awful, but I think they're going to be a lot easier than they look.
Are you DJing?
Yeah.
Are you DJing Coco?
Oh, homecoming? No. No, Titans don't ask me to dance. They have their own thing. It's fine. I don't know that it's rude.
DJ's not that great.
Well, they are happy with him, so, whatever.
I'm still debating whether or not I want to go to that dance.
Which one? The one Saturday?
Yeah.
It's going to be lit. Or something. All right, f of g of x. Windmill Museum. That's their go-to.
Why?
Why is the Windmill Museum their go-to?
Yeah.
Because it's large. Because it holds everybody.
The fun fact, the hills at the Windmill Museum are made out of debris from the 70s tornado.
That's hilarious. I believe it, though. That's kind of cool. And kind of depressing all at the same time.
There's also a building that you can see by the public library downtown that's a bit twisted because of that.
Yes, I knew that one. That I did know. 2x plus 6 over.
In the 70s?
Yeah,
Yes.
there's a giant tornado in Lubbock. It ravaged like half the city.
Yep.
Was it that far?
Is that memorial is about?
Yeah, in the 70s, right?
What?
Grammy wasn't living here, right? The 70s. She was.
I don't know when they moved to Lubbock.
Because I feel like I would hear that. I want to
Wait.
hear that story from her.
I did that.
I want to talk about it.
I did that wrong.
Is that what the Lubbock Memorial Civic Center is for? Is that memorial?
I don't know, and I kind of doubt it, but maybe.
What?
I've never even thought about the fact that the Lubbock Memorial Civic Center is called the Lubbock Memorial.
No, you did combine two problems. You did f of g and then you.
Oh,
did
you're
G of
right.
F.
That's what I get for talking and writing at the same time. So
So the way you were writing it.
this one should be that, right?
Yeah.
Thank you, because
No,
that one.
no, not the 1 minus. It's that same check plus 2.
Oh yeah, you're right.
You were writing it correct the first time, and
I
then you
was.
erased it, and I was
And-
questioning your sanity.
Well, that's fair. Yeah.
Wait, what?
I think my sanity is easily questionable often.
The G is
That's-
You kind of did.
Okay. Whoa.
Why plus 2? Isn't it 1 minus? Oh,
G.
G.
Uh-oh, now you're doing what I did.
I did.
Don't do it. Don't follow me down the path. Come back.
No, I did it first. I did it a while ago.
Okay. Now what?
Now,
You cancel out those two giant chunks. 'Cause, well, I mean, they turn into one.
Ah, but they don't yet.
No, why?
Because this is not all one fraction yet. Neither is this.
That sucks. So then you add the 2 and the negative 6 into the fractions?
We do. How?
Alright.
Imagine.
So,
combine it with
We're just getting a common denominator, guys. That's all we're doing.
So the very bottom denominator is the denominator.
This is the only thing in any denominator. So it's like, this would be like adding, this, I mean, this is easy, but this would be like adding 1/2 plus 3. We need a common denominator. Now, I know, this like dumb example, but like we need a common denominator, right? So we'd multiply times 2 over 2 and get 1/2 plus 6 halves.
Yeah, but
That's what I'm doing.
the whole bottom thing is the denominator, right?
There's,
there's also a denominator in the denominator.
that's true, there's a denominator in the denominator.
First was
I have no idea what you're talking about, but maybe, sure, yes. This is all the denominator of this, but this is the denominator of that. It's a crazy compound fraction.
and we're trying to get
We're trying to hopefully turn it into x if we're real lucky.
wait, the whole what are we trying to get a common denominator? The 6 and the 2.
This goes with this, and this goes with that. They happen to be the same denominator, which is great because that means in a second they're going to cancel. But 2x plus 6 minus 6 plus 6x over 1 minus x all over 2x plus 6 plus 2 minus 2x over 1 minus x. Now we've got extremes over means, beautiful, beautiful canceling. I'm gonna give it to you in different words because I've never taught it that way in my life. So when you got a compound fraction, if both denominators match, that cancels. And the reason they cancel is because if you take and you flip this over and multiply, because that's what dividing fractions is, right? Then the tops and bottoms are going to cancel. So if the denominators match, they cancel. Or if the numerators match, they cancel.
So it doesn't matter if they're both, it's just one.
Right, yeah, like the, yeah. So like this is not the whole thing, just psh, psh.
And if the top matches and the denominator match.
So
Then
there's
psh, psh. Yeah, okay, so psh, psh. And then we simplify the top, 2x, so we've got,
8x over
yep,
Life is confusing.
over 8, you are correct, and then
equals
equals x. Yay, we did it. Now we got to do it again. Is there a genuine question? You're like, oh my gosh.
From 2x plus 6 minus 6x.
Mira,
plus 6x
mira.
divided by 7.
Okay. 2x plus 6x is what?
Yeah.
Okay, that's where that one came from, right? This one. 6 minus 6 is what?
0.
So he's only 8x, yes?
Nice.
Great. These one, 2x minus 2x,
0. Nice, it's 0.
right? It is 0x, so, right? 6 plus 2,
It's 8.
8.
Got it.
That's what happened.
That makes sense.
You just did too fast for my brain to comprehend.
Okay. Now this one, which is probably going to be very, very similar.
Back off, looks like he's had a bad day.
He's had a bad day.
It takes a lot of brain power to really understand this.
Okay, so you gotta. This is true of like everything and every bit mostly. of what we're doing these days. And this is really going to continue to be true. Are you listening? Because I'm talking directly to you, Garrett, although this is definitely applicable to everyone. Here's something very important. Very, very important. Alexa was bringing this up last class, actually. I think it was her. I don't know. Somebody was talking about it the other day. You do not need to. You should not try to understand this.
Okay.
You understand this piece and this piece and this piece, and you put those pieces together. So the pieces, right, are, if you add fractions, you need a common denominator, right? You multiply top and bottom to get the same thing. So common denominator to add fractions, right? Extremes over means cancel. Bam. Combining like terms. You've been doing that for ages. You know how to do that. So if you try to think about this, and you've got to, if you still are, and you may be, I don't know, if you're trying to think of, okay, how do I solve this kind of problem? You're going to have to throw that in the garbage, right? Because there is no this kind of problem, especially in pre-cal. That's what we kind of learned in pre-cal versus algebra 2. In algebra 2, you kind of have mostly the same patterns, but in pre-cal, it's like, okay, here was the pattern. Let's shove a square in it. Let's make it a little bit uglier, right? So you got to, instead of trying to think about this type of problem, think about just the pieces. You know how to combine like terms. You know how to do the things. So break it. Don't try to understand everything, because if you understand everything, you're going to sit there and stare at that blank problem for an hour and a half. Does that make sense? Yeah. Good advice. Here we go. Continuing on. So.
Everything to have a common denominator.
Yep.
You multiply the 2 out into the x minus.
That's all accurate. That is exactly what we're going to do. We're going to distribute that 2 in there. Minus 12 over x plus 2 plus 6 all over the common denominator here, right? Yes, totally true. Times x plus 2 over x plus 2. Just don't forget, in the heat of battle, that when you're getting a common denominator, you have to multiply the top and the bottom. You can't just like appear it, right?
Just distribute that 2 to just the numerator and not the
Mira.
Yeah, because it's 2 over 1.
Yeah. Was that enough to get you there, or you want me to write it? Okay, great. That's basically what I was going to say. Okay. Where was I? X plus 2 minus, here we go. We're going to brain melt. Here we go. Minus x plus 6. What happened? What just happened? Yeah, that's true, but that's not what I asked. What happened to get from this to this? What did I did? I did, because it's all negative, so negative x and then plus x. Yes. And then this one, he needs a common denominator. How was the Jell-O, kids?
It was the Jell-O.
Good Jell-O. No, just kidding. Yay, inverses.
Nice.
Good.
On the test, is there gonna be one that's not gonna be an inverse?
No. Unless I make a mistake. But no. No, there will not be. Well, on a problem like this, it will be the same instructions where it says show algebraically that they are inverses. They will be inverses. It'll be great, grand, and glorious. Honestly, probably I'll jack a problem from this book or another book so that it works. And I don't have to think so hard. That's probably what will happen. What time is it? Let's see.
12:21.
All right, it's a let people go early kind of day, so that's what I'm going to do. Goodbye. Go away.
Okay. When do we have our test? Tuesday.
Tuesday would be the test.
I heard the video and I spent 30 minutes on it and I'm 2 minutes into the video.
I know, that sucks. I hate it.
I was like, after
I
the
do
punch
that.
out time, I was like, oh my god, okay, moving on.
I do that.
So Thursday's video is there already.
That's what I'm talking about.
Oh, you started working on that one. Oh yeah. Oh yeah. Did you stopped on that one big slide and
Yeah,
you
I
got to
finished
fill
the
that
slide
out.
and I looked at it after 30
Yeah,
minutes of work,
yeah.
and it's
Well, the good thing about that video is honestly, like, it's not actually that hard and it's mostly review. It's just like a lot.